Many of you are familiar with Vernier. I know a lot of you probably use them. This is the LabQuest, and this LabQuest is got a temperature probe on it. The temperature in this room was 21.2 degrees when you all were in the plenary session at 2 o'clock, and it's now risen to 23.5. I think it's the number of people or my hot air. I'm not sure which one. I prefer to think it's people and not me. But this piece of software is allowing me to view that LabQuest and to see what the LabQuest is doing. I actually can go on, and I'm now controlling the LabQuest with this. So if you're teaching in a large lab and you've got pods with students, 4 students to a LabQuest, this lets you check up and see what they're doing. Don't have to project it, but you can go and access each one of those. And then if you were somewhat sadistic, you could play with their little minds and start changing things on it while they're looking at it, trying to figure out who's using it. But the viewer software is $50, and it actually solves a lot of problems for larger labs, particularly in colleges, I might add. This is the Logger Pro software that Vernier sells. This is about the, I think, 20th year they've sold Logger Pro. I followed it for 30 years using it. It's a very sophisticated data acquisition and data analysis software. Yes, it is $229 now, but yes, it is a site license. All the teachers, all the students, and every new cohort of students who comes on campus can have access to this software. You can put it on your home computer and use it there. So it really is pretty cheap when you start thinking of the number of copies of it that you could have. It's a very sophisticated software in terms of its graphical analysis and statistical analysis capabilities, and is a little bit more sophisticated than this version, which is the Logger Lite, which is free. You can download it from their webpage and look at it, use it. It accesses, I think, 100 samples per second. Logger Pro is capable of 100,000 samples a second. So it's a lot. That's why you see a big jagged line there compared to what you would get with Logger Pro. But it is free. If you have never used Logger Pro, you can get a 30-day trial of it and download it and see if that's something that you could use in your lab. I'm going to go to the presentation as quickly as I can and try to cover the hot spots. Please don't forget to put your blue cards in, grab a card from me, and grab a catalog if you don't have one, if you've never used it. So why did I, after 35 years of teaching at 8 o'clock in the morning, every morning, teaching organic chemistry and keeping people from being doctors, that's what I was told, that was my job, why did I decide to go to work part-time for Vernier? Because I absolutely love the company. I started with Apple II interfaces, and I've been with them ever since. And Maryville College has probably close to $80,000 or $90,000 worth of Vernier equipment we've been using in physics, chemistry, and biology, and in field science courses. It's founded by 2 teachers, and all they employ are teachers. So when you call up to ask a question, it's a retired teacher you're talking to. If you ask a question about the software is written by software people with teachers sitting next to them. So they make the software user-friendly. They have one of the lowest prices in the industry. Most of the probes cost less than $100, and some much less than $50, and it's because most of those probes are made in the United States, and they're made by retired teachers who don't like to do the teaching, but they like putting things together. So they assemble the kits to make the various probes that are used. They have incredibly fast delivery, unless you're buying 65 pounds of catalogs. That took a while to get to me from Portland. They have a variety of interfaces, from the standalone interface that you can use to the computer interface. That's $329, that's $150, or the GoLink, which is a single USB that takes a single probe, that's all you can use, but it's $61, and the Logger Lite software comes with it for free. So if you're in a K-8 teacher, that may make more sense in the long run than buying these devices that have multiple inputs and multiple probe analysis capabilities. They have over 82 probes now. They add 2 or 3 every year. They have a variety of lab books. I only have 5 of them there, but every one of the lab books in the back has a CD. that has the Word copy of every one of the labs that are in here so that you can change it. You can adapt it to whatever you need in your class. If you want to do that lab but you don't want to do Section B, you can take Section B out, renumber them, and you've got the lab you can use. You buy one copy of the lab book, you can make multiple copies of the lab. Little known fact is, in the LabQuest, there are over 150 labs already in this from most of the books. There are representative labs from most of the books they sell. If you decide that you want the advanced biology labs and you want 5 of them that aren't in here, you download them from the web page and put them right in here so that they're stored in there and the students can read them at the lab station and be able to start the lab that way. For every piece of software and for every probe, there is an instructional video. They range from 3 minutes to 40 minutes. For the wireless classroom, it's 40 minutes. But you can download those as MP4s and show them to your class or use them to review. I'm going to use this probe I haven't used for a year. That's how you can use that device or use those videos. On their webpage, you can download a PDF of a Probeware white paper that Vernier commissioned an educational consultant to do. Vernier didn't write it. And it said that if you have students who use probes, they get a greater understanding and retention of information. If they use a probe and do the data analysis, it's even more. It's even a greater retention. If you're writing a grant proposal to get money to buy Vernier equipment or anybody's equipment, you probably ought to read that Probeware white paper and use it, refer to it, reference it. Vernier has a section on their webpage that said, if you're writing a grant, here are sources of money for these specific purposes. So you can go there and you can get help from people in Portland to write that proposal. Their biggest innovation now is a wireless classroom. What I've got sitting up here is I keep disconnecting it, is simply an old router, a wireless G router, a Linksys, not connected to the internet. I made it an open router so anything can access it. So if each of these devices are connected to the same network, then what appears on the LabQuest can be on my Android tablet, what appears can be on my iPad, and could be on my iPhone or my Android phone. And that means students can be in a lab. They carry the phones anyway, so this would allow them to acquire the data and actually to control the LabQuest as well and collect data and have it stored on these devices, and then use the applications for Android or for iPad to manipulate the data and plot it and write their lab report, so that it's all done with a device that many students come with every day. Perhaps you shake them down at the door and put them in a box so they don't use them, but in a lab situation, that wireless is a great ability. Originally, they set up an ad hoc network using a piece of Apple software, Bonjour. But I'm telling you, this is a far better way to go because your IT boys don't go ballistic. Because it's your network, you're not accessing the internet, you're just allowing all these devices to communicate with one another. They also sell a variety of lab equipment. Stir stations operated by D batteries, so they're much cheaper than the stirring magnetic stirrers that Fisher or somebody else sells. They have a Vernier dynamic system with carts for physics using the motion sensor to detect the movement of the carts, but that track serves as an optical bench as well for all their optical devices. So once you buy the track, all you have to do is buy $130 worth of lenses and light sources, etc., and you can do the optics. I mentioned the lab books. You can go to any of the lab books on the website and look at each one of the labs and decide, is this a book that I could use that fits what I need? If you want to know whether it fits the current Tennessee science standards, if you're teaching a Biology 1 class, you go to Tennessee Biology 1 and it correlates every one of the current state standards to one of the lab books and the probeware and the hardware that you need to do that lab. There are 2 people at Vernier that do nothing but keep up with all the changes in the state standards. Not a job I want. But that's essentially what they spend their life doing. If Tennessee, I hope and pray they do, goes and adopts the next generation science standards, when they finally finish deciding that, then they will upgrade this almost instantly as soon as they are notified that Tennessee has adopted them, so all of those standards will be changed. So it makes teaching a new course, if it's a new course for you in science that you haven't taught before, it gives you a way to see what could I do in lab and what probes do I have now and what do I need to do that. These are the 3 data collection devices I mentioned. The LabQuest is the latest generation. It means I don't need a PC in the lab for each lab station. I only need the LabQuest. The LabQuest, if you've got one of the original LabQuest, the LabQuest 2 has a much bigger battery. It lasts about 8 hours, which means field work is really much easier. It has a built-in wireless adapter. It has a built-in GPS unit. So if I wanted to sample the pond down here for pH, I could go around that pond, dip the pH probe in, measure the pH, and hit GPS. And the coordinates of the GPS are tied to that data. Then I can go on Google Maps and export that data, and at each place around that pond where I took a measurement, there'll be the pH listed at that particular point. So for field work, it's incredible. And having that 8-hour battery makes it much more valuable. For any probe, if you've inherited some probes at your school and you don't know what you can do with them, this tells you which of the devices they'll work with. And even for the older device, the Lab Pro that they sold a lot of at $229, Maryville College has, I think, 80 of those that we use in biology, chemistry, and physics. And it tells me which of the new probes will work with them. These are the 2 apps that you can download from the iTunes Store. You can get the graphical analysis for iPad for $4.99, or your students can, and they can get video physics. I can throw a football from here to the other side of the room, use the iPad to video that, and then stop frame the video and mark the position on an XY coordinate and translate that data into an arc of to be analyzed for the physics path and the acceleration and velocity at any point. They continually come up with new sensors, a radiation sensor, an ethanol sensor, the new dissolved oxygen probe that is an optical probe rather than being a chemical probe. I have some of those sensors. There's a UVA and UVB wavelength sensor. The new radiation probe is relatively inexpensive if you're still teaching radiation chemistry or radiation physics, and it works very, very well. We talked about that. There are several things about STEM specifically. This is a digital control unit. This digital control unit has an output in voltage, depending on what voltage I plug in there, up to 12 volts. I can use the LabQuest Mini. What I've got is a magnetic field sensor and a magnet on the back of my door. So when the magnetic field, I can, in Logger Pro, I can say when the magnetic field drops because somebody opened the door, that sends a voltage through this to my little piezo buzzer and it'll start buzzing. So you could ask a student, all right, you did it with a magnetic detector, how else could you do it? You could use a motion detector. When the motion detector doesn't detect the door, but somebody standing in front of the door because that's a greater distance away, that sets off the sensor. Or you could use a light source coming from this side and a light sensor over here, so when the door is closed, there's no light coming through, but when it detects light, that sets off the beeper. So you're really doing a design for a particular purpose. The DCU is $61, and you use Logger Pro to control it. And it's very simple. If the magnetic field is less than this, send the voltage out channel 1. You can use it to control stepper motors and lots of other things. If you do the Lego Mindstorm, there is adapters so you can use the probes with your Mindstorm. If you have students using LabVIEW in an advanced physics class, this is the software that most engineering schools use to program. It's a graphical analysis program. They can use all of the probes with the LabVIEW hardware. They have 2 STEM books for Lego Mindstorms, and again, if you're thinking about using those, go look at the lab books and see. I'll have these specific sensors tomorrow so you can come look at them, but I wanted to suggest that in the catalog, if you look at the various probes, you know, I've got an infrared, a surface temperature, an extra long, or a thermocouple, or the stainless steel, or the expanded range. There's 6 temperature probes. How do I know which one to use? Well, if you go on Vernier, this is my boss, David Carter in Nashville, and David has made videos for about 80% of these probes and software. The rest of them were done in Portland at the home office. But you can access those on the Vernier website and watch his 10-minute video where he said this is what each of those probes will do and how you could use them. When would I use a surface temperature probe as opposed to an immersion probe, etc. So those videos make that a lot easier for you to choose. If you do get money, you can go and look for a subject area. What do I teach? What does Vernier recommend as a set of probes and the data acquisition devices that go with each of those books? So you can get that information as well.